In this lesson, we're going to be talking about multiplying and factoring polynomials. Let's go ahead and find the product of these first two examples. In the first example, you can see that we're taking a monomial and we're multiplying it by a binomial. It looks a lot like the distributive property, which it is. The only thing we're doing in addition is we're applying our knowledge of the laws of exponents. So let's go ahead and distribute negative 6x into the binomial. So negative 6x times 5x is going to leave us with negative 30x squared. That's where our laws of exponents come into play. Now let's take negative 6x times negative 3. That's going to simplify down into positive 18x. And there you have it. You've multiplied the two polynomials together. Now let's take a look at a monomial times a trinomial. It's going to work the same way. Let's take our monomial and let's distribute it into our trinomial. 3x squared times 4x squared is going to leave us with 12x to the fourth. And then 3x squared times negative 5x is going to leave us with negative 15x cubed. And we get the cube because, don't forget, there's a little invisible 1 here on this exponent here. And then the last one, 3x squared times positive 2, is going to leave us with positive 6x squared. And there you have it. Now, those were two examples of multiplying a monomial by another polynomial. Now let's go ahead and take a look at what happens when you multiply binomials. So anytime that you're multiplying two binomials together, you can use this procedure called foiling. Foiling stands for first, outside, inside, last. And those are the steps that you're going to take in simplifying the problem. So let's look at the first one. Notice how I have a binomial times a binomial. That indicates that I can use this foiling technique. So I'm first going to multiply the two terms that are in the first position in both binomials. That's going to be 7x and 4x. When you multiply those two terms together, that's going to give you 28x squared. Then we're going to move on to the outside terms. So the two outer terms, which is 7x times positive 7. That's going to give us 49x. Then we're going to move on to the inside terms, positive 1 times 4x, leaving us with positive 4x. And then last represents the two last terms. Positive 1 times 7 gives us positive 7. Anytime you simplify or multiply two binomials together, it's going to give you 4 terms. And those two center terms are going to have the same variable, and they're going to be like terms. So you always want to take it one more step and condense this down. So let's go ahead and simplify it to 28x squared plus 53x plus 7. And there you've simplified them, or you've multiplied these two binomials together. Let's try another one. We see that we have two binomials, so that means that we can use the foiling method. I'm going to start with the first two terms. So 6x times 8x. And by the way, you don't need to write these little loops in. These are just kind of there for a visual for you. So 6x times 8x is going to give us 48x squared. So I'm going to go ahead and write that down. And then outside, the two outer terms are going to be 6x times positive 5, giving us 30x. Inside, my two inner terms, be really careful with the negative there. Negative 5 times 8x gives us negative 40x. And then the last two terms are negative 5 and positive 5, giving us negative 25. You should see those two terms in the center, and they should be able to be condensed, or you can combine them. So that'll leave us with 48x squared minus 10x minus 25. And that is how you multiply two binomials together. Okay, I do have two more examples of multiplying binomials, and we are still going to be foiling these two, even though they look slightly different. So in this first example, it's a little different because this time we actually have two variables. We have an x and we have a y. It's still going to work the same way. So I'm going to go ahead and multiply my first two terms together. So first two meaning the first two in each of the binomials. So 7x times 2x gives us 14x squared. Outside is going to be 7x times, see here, 2y. So this term is going to look like this. It's going to be positive 14, and then I'm going to write xy. xy is its own type of term. Okay, inside, negative 8y times 2x is going to give us negative 16. And I noticed that I have an x and a y, so I'm going to write in xy as well. You can see that those two terms are going to be able to be combined in the end here. And then last, negative 8y times positive 2y is negative 16y squared. So here we can go ahead and, again, these two center terms, even though they have two variables, they can still be combined because the exponents on those variables are the same. So those are like terms. So that's going to give us 14x squared minus 2xy minus 16y squared. And you're done. And then the last one, it says here we're multiplying binomials, but that doesn't look like multiple binomials there, but it actually is. And this is a there's a very, very common mistake that occurs with problems like this. And let me show you where it is. Sometimes our brain says that we're going to take each one of those terms and raise it to the second power, but that's actually not what this is saying. This is actually saying that we have two binomials here, and let me go ahead and write them out. One binomial is 5x minus 3y, and then we also have another one that's identical. It's saying we have two of these binomials. So be careful not to raise each of these to the second power and get something like 25x squared minus 9y squared. That is incorrect. Once you've rewritten these two binomials, then you can go ahead and FOIL. So I'm going to go ahead and do first. It's going to give us 25x squared. And then we're going to do our outer. That's going to give us negative 15xy. Our inside. And that's going to give us negative 15xy again. And then our last is going to give us positive 9y squared. You can see that those two in the center are able to be combined, leaving us with 25x squared minus 30xy plus 9y squared. And there you have it. All right, let's do one more multiplying, one that we haven't done so far. Let's multiply a binomial times a trinomial. It looks pretty complex, but really all you're doing is the distributive property twice. What I mean by that is pick one of your terms. I always like to start with the first one. And I'm going to distribute 5n into each of the terms in the trinomial. And be very nice and neat and organized as you do this. So let's do this. 5n times 2n squared is 10n cubed. The second term would be 5n times negative 5n would give us negative 25n squared. And the third term would be 5n times 5 gives us positive 25. Now I'm going to go ahead and choose a different color just so you can see the difference. Now I'm going to go ahead and take negative 8 and I'm going to also distribute it into all three terms. So negative 8 times 2n squared gives us negative 16n squared. Negative 8 times negative 5n gives us positive 40n. And negative 8 times positive 5 gives us negative 40. And be very, very careful with all those operations because you don't want to make a mistake that's just an integer operation. Now we're going to piece it all together. So to piece it all together, we have to just basically look for all of the powers that are the same and combine them. You can see that 10n cubed is in a land all by itself. So we're going to go ahead and use that term. Now I can go ahead and I can combine negative 25n squared minus 16n squared. Do you see that? So that's going to give us negative 25 minus 16 is going to give us negative 41n squared. So I've combined those two. Now, to put this in standard form, try working with the terms that are in descending order by degree. What do I mean by that? The next term would be this, positive 40n, because that would come next in line. And he doesn't have anything to combine itself with, so I'm going to go ahead and add 40n. And then, of course, the last ones are just constants. So I'm going to go ahead and combine them as well. Positive 25 minus 40, leaving me with negative 15. And there you have it. You can see that your binomial times your trinomial is going to give you a cubic polynomial. Okay, now that we've talked about multiplying polynomials, basically what we were doing there is we were kind of like putting it together, I like to say. Now what we're going to do is we're going to begin talking about factoring, which means basically that you're breaking something apart into all of its pieces or all of its factors. So let's go ahead and talk about what is the greatest common factor. So looking at this first one, I'm going to break the first one down so that you can see what I mean by the greatest common factor. I want to be able to break down each of these terms into all of its pieces. So we could break down 12x. You're probably thinking something like this. You're probably thinking, well, 4 and 3 and x, right? Because 4 times 3 is 12 times x. That gives us 12x. But then we can also break down the 4 into a 2 and a 2. And then, of course, we have our 3 and our x. And you can see that these are the lowest pieces, are broken down into the smallest pieces that make up 12x. Those are called factors. Okay. Now let's look at the 6x squared. I'm going to do this in a different color so you can see. 6x squared, you might be thinking, well, 3 times 2 and then times x and x, right? And you don't even need to write the multiplication there if you don't want to. But I'll just do 3, 2, x, and x, because x squared is just 2 x's. So that's actually, I can't break any of those down at all, so I'm just going to go ahead and put a little box around those, because those are my lowest factors. And then the last one, 2x. Well, that can be broken into 2 and x. Those are my smallest pieces I can break it into. So when it's asked to find the greatest common factor, I'm looking for the biggest factor that is common in each one of these terms. So looking at the blue box and the orange box and the purple box, it looks like the greatest numerical value or coefficient in our sense is a 2. You can see that I have a 3 and a 3 in the blue and the orange, but I don't have a 3 in the purple, so it's not common. So I have a 2. And I have a 2, and I have a 2. So the common coefficient is 2. And then you can see that I have one x here, I have another x here, and I have another x here. So that's going to give me a greatest common factor of 2x. And you might be wondering, well, the orange one has another x in it. Yes, but the blue and the purple do not, so it's not common within the 3. It has to occur in all 3 of the items to be a greatest common factor. Now, you don't need to break these all down each time unless you want to. But let's go ahead and take a look at this next one. I want to know what the greatest common factor is. And another way to do it is just to kind of break it down by component. So just think about 5 and 20. 5 and 20, the greatest common factor that goes into both of those numbers is 5. So 5 is our coefficient. Now focus your attention on the x's. Notice we have 1 x in the first term and we have 3 in the second term. So the greatest out of both of them would just be 1. So 5x would be our greatest common factor. Now look at this big one. three terms here. Let's figure out what the greatest common factor is with this one. Now, I have an 18, I have a 60, and I have a negative 24. If I just focus my attention on the coefficients of 18, 60, and negative 24, the greatest common factor that's in all three of those numbers is going to be 6. So I'm going to go ahead and write 6. Now just focus on the A's. I have 3 in the first term, I have 2 in the second term, and I have 2 in the third term. The highest out of all three of these is going to be a squared. I understand that the first term has 3 A's, but it doesn't have 3 A's in the other two terms, so it's not a common factor within all three of the terms. And then I have B's, B, B, and B squared. So the highest B factor can only be plain old B. And there's my greatest common factor. Now that we understand what a greatest common factor is, let's go ahead and learn our first factoring technique. This factoring technique is called factoring the GCF. This is always going to be your first step in factoring any polynomial. So basically, anytime the directions say to factor, the first question you ask yourself is there a GCF, a greatest common factor? So let's look at this first example. I have 36x squared minus 42. And we ask ourselves, do we have a greatest common factor? And we do. The greatest common factor in both of these terms is going to be 6. So I'm going to write a 6. Then I'm going to write parentheses because this is how you factor. The question I want to ask is, what is left over when you pull out a 6 from 36x squared? What is left over? Another way I could ask it is, if I were to distribute 6 into a term, what term would give me 36x squared? You might be thinking, well, 6x squared, right? Because if I redistributed this, it would give me 36x squared. I want to do the same thing with the negative 42. I want to ask myself, 6 times what gives me negative 42? And the answer here is negative 7. So what we did here is we factored, as far as we could, we factored this binomial into its smaller pieces. Now, if you wanted to check yourself, of course, you would redistribute 6 into the binomial, and that's called multiplying polynomials, which we just covered. But for right now, it does say factor, so we're going to leave our answer in factored form. Let's take a look at another one. Let's go ahead and find the GCF. So the greatest common factor with all three of these terms looks like it's going to be 3a. So I'm going to write 3a, that's my greatest common factor, followed by a parenthesis. And then this is where I want to break down the pieces. 3a times what gives me 30a to the fourth? Well, 10a cubed. I can always double check it mentally. Then 3a times what gives us negative 24a squared? Well, that's going to be negative 8a. Then 30a times what gives us 9a? Well, that's just going to be plus 3. And that's it. You've factored your polynomial. These are all of the factors of this polynomial. Let's try a couple more. This one's a binomial. Let's go ahead and factor this binomial. Let's pull out the GCF. The greatest common coefficient is going to be 7. The greatest common a is going to be a squared. The greatest common b is just going to be b. I'm going to go ahead and close the parentheses here and ask myself, well, what would I need to multiply that by to get that 14a cubed b squared? Well, 2ab. If I multiplied 7a squared times b times 2ab, it's going to give me that term. Ask yourself the same question here. You might run into a little issue here. You might say, well, there's nothing I can multiply it by to give me that negative 7a cubed b. Well, actually there is. How about minus 1? There you've put it into factored form. Each of these two pieces are called factors. Last one here. Okay, let's look at the coefficients first. You can see that I could probably pull a 10 out, but there's not a greatest common factor of 10 in the third term. So it actually looks like I can't pull out a coefficient, but I can pull out an x. So I'm going to go ahead and pull out an x from these three terms. In the first one, I'm going to be left with 10xb. In the second term, I'm going to be left with minus 90x squared b. And then in the third one, I'm just going to be left with a 1, because if I distribute x times 1, it's just going to give me x. And these are your two factors of this polynomial. And that is your first step in factoring. Anytime you're asked how to factor or to factor something, you always want to start by asking yourself, can I pull out a GCF? All right, that brings us to the end of our lesson on multiplying and factoring polynomials.